It's great to see you all. I think most of the people will start joining as well. We could probably start with introductions from the start. Uh, I am Sravya Madipalli. I lead growth data science team at Superhuman. It was previously Grammarly. It's now we are now Superhuman. I have experience at Microsoft and a bunch of places like at eBay and then Nextdoor. That's where Sean, Hi, and I met actually. So Sean and Hi are part of my team. And Sean and Hi, do you want to share a bit of intro about yourself too?
Yeah. So, hey everyone, my name is Hai, and I'm the head of data at a legal tech AI company called Entra, and previously worked at big tech in Nextdoor, LinkedIn, Pinterest, Meta, so on and so forth, leading data science teams. So, really happy to be here and speaking to you all.
Hey everyone, I'm Sean. I'm a principal data scientist. A lot of the work I do is around AI evaluation, AI analytics. Yeah, been in data science for about 10 years. One thing I like to do in the beginning of these things, I'm located in South Lake Tahoe, California. Where's everyone coming in from? Because usually we have a pretty international, drop it in the chat where you're from. Yeah, Northern Utah, India, Toronto.
Awesome,
Yeah,
love
it's so
it.
cool, like where everyone's from.
Oh my God, I can imagine from India. It's so late there. Great, you guys are interested in joining us from India as well, and a bunch of other places, pretty cool places.
Ben W.,
Nice.
I'm probably 5 minutes away from you. You're in Pacifica Bay Area.
Ah, nice,
Yeah.
nice. So exciting, so exciting. Okay, we have a pretty packed agenda today, guys. So as soon as I think we're getting most of the crew in, and probably maybe one last question about before we get started, what is something that you're looking forward from this session? Anything interesting that you'd like to share in chat? While the new people who are coming in could share about where they're coming from. Okay, okay, good. Yeah, cool. Sure, that's fine. I think I'll probably get started. Let me start sharing my screen. Yes, we're going to cover all of that, guys. Like I love all the great responses. So, can you all see my screen? Okay, I see a yes from Sean and Han. Cool. So, what are we going to talk about today? We're going to talk about running and analyzing experiments with Claude Code. Yes, I talk about Claude Code here, but guess what? We also do Claude Web UI because I know that most of you could easily access Claude Web, and we have some interesting things to share with you at the end as well that you could literally take out of attending this free lesson and use it in your day-to-day work. Okay, so let's get started. By the way, I'll be presenting today, and any questions that you have about what I'm presenting, and any questions about other things that we do at AI Analyst Lab.ai, please push push through your questions in the chat, and we'll have Sean and Hai reply to you as well. Cool. So let's just get started. Okay, let's start with a quick poll. Can you answer to this question? You could type A, B, C, or D. No judgment at all. Based on what you all feel like. Give me a minute. I can't access the chat. So, Sean and Hi, if you see something, you could respond to them.
Got a lot of
But
C's. We got a lot of C's, a lot of high performing experimentation folks here,
oh,
and some
that's pretty
B's.
cool.
All C's, most.
Oh, nice. That's so cool to know, actually. We generally try to cater our presentations to everyone because what we try to do here is something that get people who are not as experienced, people who are stakeholders, not even data scientists, how do they get on board into understanding experimentation and how could they, get all the technical details and help from Cloud Code. So it's absolutely okay, even if you are like an A or B, or even D, So there's no judgment at all. But glad to know that most of you are Cs. But let's get started. Today we'll probably try to do the C that most of you all do, but how do you do it with AI? Cool. So I'm doing it the other way this time around. I want to show you what is the final output that Claude Code gave me. And let's then dive into the theory behind experimentation because I wanted to share with you all cool things. At least it was pretty cool when I tried to test it out. Let's see if you all can see this. Okay, so this is the prompt that we gave. So this is our repo that we work off, pretty detailed. We have a bunch of agents, like we have a bunch of things going on. And in the repo that I have my data file, this is what I gave as a prompt. Analyze experiment, and this is the CSV file that I used, which contains Streamflow data of an A/B experiment. And using the experiment analyzer agent, this is the agent that we've built. And these are the inputs I gave it. And I gave it some context around what business context around what is what is the average lifetime value and things like that. And it also has access to a bunch of questions and analysis that you have to do when you are given like an experimentation question, right? And then I ask it to do a final readout in a Google Doc. I literally paste this thing. I don't do anything else. You could actually also talk to it with WhisperFlow if you want to. But let's say I pasted this, right? I'm going to go through the entire demo with you if we have time at the end, but I wanted to show you the end result. So I'm sharing with you a window. Let me stop sharing and share with you what the output looked like. Where am I? Yeah. Okay. So do you see my Google Doc? This is the Google Doc that it generated. Streamflow regional playlist experiment. This is like a demo output, as you see. It has the executive summary. It has question after question, like a table with the details and like what happened to these metrics. What's this reliability? How does it look like for deep dive segments? And I don't want to get through the details because there's some interesting stuff that I want to share in the demo directly. But I wanted to share with you that this was the output it generated with one prompt, one single prompt in our repo, and that's what we got. Isn't that cool? What do you all think? Would love to know what you all think. And let me get started with my presentation back again. Cool. So now that you saw the end result, I wanted to share with you how we got there. What are the multiple pieces that go into this brain of how did it come up with that output, what went into it, and details. So before that, I want to share with you something. So if you want to build this reusable system, like one prompt in and an output out, obviously you'll have to do some feedback and checking and a bunch of things. But if you want to understand this, how we build these agents and skills, we have an AI analyst bootcamp coming. It's a 2-day weekend intensive program. We have way more than experiments covered there. We also talk about funnels. We talk about root cause analysis, storytelling. Like how do you actually get this to present in not just a doc, Google Doc guys, but also a deck, like a presentation. I have a demo of a presentation that it did as well. I'll share with you at the end. But we cover all of that. And for the people who are attending this lightning lesson, both live and also who have signed up, we have a code for you, Claude20. Please try to use that and leverage this to get $120 off. This is our first attempt at doing this bootcamp. I know a bunch of my friends and all the people I know, they're like, you're giving this for way smaller amount than usual. But we wanted to share with you all everything that we are learning and pretty excited to share that. The other thing that I want to share is we have an open source repo. We have this in GitHub with like AI Analyst Lab /AI Analyst. Sean, Hi, and myself share a bunch about this in our LinkedIn post as well. Please try to, get this open source repo, clone it, and see all the things it could do. Share us your feedback. What we teach in the Analyst Bootcamp has a lot more things than what we have in the repo. We are actively building what we share for the bootcamp. Another interesting thing as well, we have a Slack community. We currently have 250 plus members, people growing by the day. People come in, ask questions. You could free to join anytime, and we are there to help, navigate through any challenges that you're going through in this space. This is a QR code to get into the bootcamp, guys. Yeah, cool. Now, let's get started again about the problem. So here's a common pattern we see with experiments. We turn it on, we wait, read the dashboard, green means ship and red means kill. I know a bunch of you are already doing great things when you mentioned that you do the entire analysis, but I'll be honest, from my experience, not everyone does the entire workflow or a life cycle of how experiments need to be done. Especially when we want to ship things very fast and move fast, that's when we see this happen a bunch as well. So when you do based on just pure green means ship, red means kill, it's almost like traffic light watching, right? So the problem is that treating experiments as a single step instead of a life cycle. So today I'm going to show you the entire life cycle, the different stages, what are the common ones that kind of get skipped, and then we'll demo what happens when the obvious ship it answer turns out to be wrong. Cool. What's experiment life cycle? I think a bunch of you who are data scientists that work in this space probably already know it, but for people who are stakeholders and are newer to tech, I'd like to share this in deeper detail, right? So it starts with why, why are we experimenting in the first place? And the design, how do we want to design this experiment, right? And what is the power? Like how long do you want to run it and how many users? And how do you want to, like, once you start running it, what are some things you need to check for? And then once we reach our, the goal of running it for a certain amount of time, how do we analyze it? And what do we decide on? Do we ramp it, kill it, iterate on top of it? And then how do we want to ramp it? So we'll cover all of this. Let me know if I'm going too fast, guys. Hi, Rashawn, please interrupt me if there's something in the messages that you want me to stop. I'm currently directly diving in because there's so much content I'd like to share.
You're good. We're managing the chat, but I'll interrupt you if we need to answer something directly.
Okay.
Yeah.
For a while, I was
Shout out
like,
to Sai, already registered for the bootcamp.
oh, that's awesome. Okay, cool. I'm kind of feeling like I'm giving a big monologue, guys. So please, you could interrupt me or share anything. So, okay, let's get back to this. So, why do we experiment, right? So, products go through this life cycle. We first build and we want to measure what we build and then we learn, right? So, experiments basically, so this isn't new. It's the way the lean startup loop works. So, experiments are the most critical ones that we are discussing today, are in the measure step. Without them, your PM probably would say, hey, I think user wants dark mode. And your designer would say, oh, onboarding is way too long. And maybe your CEO would come and say, just change the pricing, guys. This is like there's a lot we could do here. So all of those are just opinions until we go test them. So how do we go test them? We first start with design, right? So step one is basically design the experiment before you build anything. Start with a hypothesis. And if you notice the structure, we have something like, we have this like, we believe this change will impact this metric because of this reason. The because forces you to articulate why you think this works. That's the mechanism. Then pick one North Star metric and a guardrail. The North Star is what you're optimizing for from this experiment. And the guardrail is what you refuse to break. And I want to give a quick plug-in about, we did a free lightning lesson on how do you define metrics on this. Hai actually ran it a few weeks ago. So if you're interested, please drop in the chat and, Sean and Hai could respond. Also, you could go to aianalystlab.ai. There you could see a bunch of free lessons that we've, we've shared in this area, and a bunch of things that are coming in future as well. Okay. Now coming back. Here in this lightning lesson today, we are going to have a running example of a Streamflow dataset. So what is the experiment that we are going to have that will run through this entire lightning lesson? We believe showing regional playlists will increase weekly streams because users engage more with music that reflects their local culture. So that's the hypothesis. See, if you look at it, we have a because, right? We think because of that, it reflects the local culture and there'll be more people who'll engage with it. So this is our statement and this is our experiment that we'll run with. And the North Star that we are aiming to improve is streams per user, and the guardrail is churn rate. We don't want people to churn, right? We want them to engage. So we want to ensure that that guardrail is met. Cool. Now that we have the statement, the hypothesis, the because, the reason, we need to understand how long do we want to run this experiment for, right? And how many users do we want this experiment to be, exposed to? So what is the effect size? So is 10% lift easy to detect? So if you look at it, 10% lift probably is slightly easier to detect when compared to the 1% lift. 1% lift in like control to treatment would need way more data, right? Specifically for a significant level, it's usually around 5%. That's an industry norm. And power usually is around 80%. That's another norm that we deal with. So for this analysis, after the power analysis, what we came up with is 6 weeks and 25K users. So what happens, let's say if we skip this? Most of good teams don't skip it, but there are a bunch of teams that I've seen skip it where they think they have this knowledge already from the past experiments. They have the domain hypothesis, and then they want to move fast. Let's say they're blocked on the data scientists. They skip these things, and what happens when you skip them is you run too short and you miss the real effects. And there's a bunch of peaking also that happens. Let's say on day 3, someone sees a significance and it's such big of an effect. They're like, oh, why do we wait on getting the impact on this experiment? So let's ship it. And then they ship noise because it's just day 3, right? And another thing also happens when you don't do the power analysis and all of this the right way. You basically can't tell if a null results or no means actually there's no effect, or it doesn't mean you don't have enough data to talk about it. Basically, there's not enough power to say you know something, you learned something, right? And like probably the data science folk in this meeting would know that peaking is like the most common way good experiments get ruined. Okay, so this is a small sneak peek about what our existing free repo already has. So this is an experiment design pipeline that we have. It basically comes up with a hypothesis. The power calculation and what exactly happens in the design and what are the guardrails, and running happens right after this. So every good experiment follows this structure. The system auto-generates all of it once you give it enough context. Hypothesis, power analysis, randomization of design, guardrails, and the full pipeline, including the decision rules, also is part of like the next stages, right? So today we are picking up after once the design is done, how would the experiment run? So that would be part of my demo, but I want to share you a sneak peek of what would be if you run it, the design skill that we have in the design repo today. So these are literally the charts that it created for the experiment that we are going to talk about today. So on the left, you have a feasibility curve. What does it show? It basically shows you how many weeks you need to detect different effect sizes. A 5% lift needs around 6 weeks. A 3% lift, we need 16 weeks. Wow, that's in the patience zone, right? And on the right, you have a power sensitivity matrix. Each cell shows basically your statistical power at different combinations of effect size and sample size. The green boundary is where your test becomes reliable. So 80% or power or above, basically. So notice that at 12.5K users per arm and a 5% effect, we hit exactly 80%. That's why the Streamflow experiment, if you remember that I gave you this number before in the design, basically it talks about having the experiment run for 25K users over 6 weeks. And all these, to mention it again, these charts are auto-generated by the system that we have. Cool. Yeah, so now let's talk about running and deciding. So what do we want to do once, we basically are condensing 2 steps in this stages here to explain you the theory. We'll go through this in detail if we have time in the demo. So we are condensing 2 stages here. While the experiment runs, check for the SRM, right? Sample ratio mismatch. Is the randomization clean or not? You probably need to watch out for the novelty effects. Early lift because of, it's an exciting new feature, probably, right? So a bunch of clicks come from that, but not all of that stays the same. So early lift uh, fades if it's not real. And when it's time to decide, you ship, kill, or iterate it, right? And then remember that the statistical significance does not always mean practical significance. Basically, a tiny lift that's significant for us, it feels like experiment is a win, but it might not be worth shipping because it adds complexity. This is something I deal with day in and day out in my current job, in my previous, in all my experience. I'm sure a bunch of you who are from data science also deal with it a bunch. That what is, good enough to ship, even though if it's like a win. And when you do ship, not every experiment have to go through this 5%, 25, 50, 100%, but the ones that affect your ecosystem of product, if it changes a bunch, you probably go through that. But another important thing that I see a bunch of, teams miss is having a holdout. So ensuring that you ramp gradually, especially in case of important, like, UI changes or something that affects users. You basically try to ramp gradually, and you always keep a holdout. So the experiment doesn't end when you just say ship it. It doesn't mean that you're done with it. Yeah, so this is what covers what I just mentioned. So you monitor it at each stage, especially for the important changes. You basically ramp gradually and you monitor, right? And you understand, and you also add a holdout to understand the long-term effects. There are like a bunch of experiments that actually show great results probably at a later stage. For example, I have experience in working with engagement of the product. Let's say top of funnel is engagement and bottom of funnel is revenue that you get from these users. Unless you have like metrics like lifetime value, which predicts the revenue that comes out of these users, it's pretty hard for you to see engagement show an impact on revenue in the experiment timeframe. But guess what? If you add all these engagement driven experiments that are wins to your holdout, what you'd see in over 6 months of time is that you actually see a great improvement in revenue coming through. And imagine if you have a holdout for like a year or so, let's say in a scenario of you have it for 5 years for some, and to understand, the long-term effects of improving engagement is going to be so much higher on your revenue. But you cannot understand that in your 2 week, 3 week, or maybe 4 to 5 weeks experiment standpoint. And that's the reason it's very important to have a holdout.
Hey, Sravya, sorry, can I interrupt real quick? So I know the design experiment skill is in the repo. Is the full experiment workflow in the repo as well, or is that something you've been iterating on your own?
So the full experiment thing is something I'm iterating on. I'm planning to add it for the bootcamp. So currently we have the design one though. So you could actually play with it yourself and see what else, need to be done to it. So the repo itself is pretty smart and intelligent. It has a bunch of things in itself. So yeah, I'll probably talk about it more when I go through the entire like demo. Hopefully we have time. I'm trying to go super fast to get to the demo. We'll see. Awesome. Yeah. Thanks, Sean. Yeah. Please interrupt me like this. Cool. Okay. So these are like these are like 8 questions that I see, like, separate like a good analysis from great. So not every experiment needs all 8, I'll be honest, but knowing what to ask means you won't miss those things that matter, right? So the one thing is basically understanding if the experiment set up correctly. Did the treatment move the metric? Like, what is the reliability? So one thing that I see people miss when they're, in a hurry to ship something before a quarter end because they want like wins out is what are the learnings that you have from the experiment across segments? These are something that you wouldn't know unless you dig deeper into understanding, what happened for probably users that are newer when compared to the mature users, Like asking these questions to look through multiple segments would really help you, not just for that experiment, related, decision making, but also all the new iterations that you want from your experiments, like that you have in the quarter that are in the backlog that you want to run with your product team, product dev and engineering team. Okay, so today we basically are going through all of these through the Streamflow dataset. I'll actually give you exact prompts to do it yourself in Claude Web UI. And we'll have like a one-stop shop prompt, and we'll have like multiple prompts for each of these stages as well. Okay, time for a live demo. Cool. So let me just stop sharing here and share my screen and get started. Where am I? Okay. Give me 1 minute. If you're trying to, okay. Let's go back to the demo. Let's say we have our Claude UI right here, okay? And what you're trying to do here is I have one that I already ran it. If for some reason we're going to have issues with my internet or I don't know, Claude usage, we can look back at what I ran it. But let's do this live, guys. We have some time. So I have the data set. This is a data set we've generated for this. And I'm going to give this prompt. So, okay. So what am I doing here? I basically gave it a prompt that I've uploaded a data set. I gave it the context of what the data set is. I gave it what the columns are, what each columns, almost like a data dictionary, right? What each columns are. And I tell it like, what should be the step 1 be? Like, what do you look for? Like sample review mismatch, the pre-experiment balance, and the duration check. What's the date range? How many weeks you want to run it and stuff. Let's see what it comes up with. One thing I want to let you all know is this is something that I'm facing right now in my company when I'm trying to do things. The column names, so I didn't give it what are like each of the columns mean here, right? For example, if you don't give, like you don't have a data dictionary of what each column means, what Claude or like maybe any other LLM does is it understands based on what a column name looks like. So we basically had this issue where, let's say there's a column name called anonymous. It takes that into context of what it knows and just takes it as like comes up with its own assumption of what a column name could mean and goes and run with the data. So be very vigilant when you give column names without what the column names mean. In this example, it's pretty obvious. I kind of created the data set for the simplicity. I made it so that each column names actually mean what the name what you could assume based on the name. But if you're trying to do this at your work, ensure that you also give what each column actually means, because not all column names are pretty descriptive. Now let's see, what did it give me? So it went through the step 1, the sample ratio mismatch. It basically looked at the split and it gave me a pass, the verdict. It's pretty cool. No evidence of a randomization or a logging bug. And then it basically looked for continuous covariates. It came up with what are the categorical covariates, and like proportions are virtually identical across arms. It made sure that what we are looking at is a pretty balanced data set. And then it came up with the duration check. The experiment spans for 6-week cohorts, and it gave me from when to when. And like it also identified a small concern about the weeks 5 and 6. And basically, this is what it says. Like it's something that this is like worth investigating in step 2. So that's what we'll go ahead and do in the step 2. How much time? Okay, we have 30 more minutes. I'll try to do the Claude Web UI like demo for the next 5-10 minutes, and I'll run in another demo and go through how my workflow looks. What is something that I've built for this lightning lesson for experimentation in the Claude code after this. Cool. So it's currently thinking through what basically my prompt is that I'm asking it to do the treatment effect and also the reliability. I'm telling it what tests to run. what is the experimentation t-test I want to run, and how I want it to be displayed. And I also talk about the effect size. Can you give me the effect size? And look, and also I talk about like what is the post hoc power? Like, do you give the observed effect size and sample sizes? What is the power we achieved? I also talk about minimum detectable effect. What's the smallest lift we could have detected at 80% power? And I also ask it to give me a one sentence summary. Cool. Look at what it's giving me. Exactly what I mentioned to you guys that I asked for. Um, and yep, so look at the one sentence summary. The treatment increased by 14%, right? Which is statistically significant. So guess what? Looks like we have a winner here, guys. We have our not like we have the metric increased by 14%, which is amazing. So there is something that you would see that most of the people would probably go. There are a good chunk of people that would probably tell and announce that, hey, we have a winner because we ran it for the amount of time we wanted to run it. So they did their diligence, they didn't peak probably, and they got a winner. Let's look at the step 3 and do the segment analysis and think through and look through if what we have is actually a winner or not. So this is a longer one because I'm asking it to look through and break results by all my important dimensions. So the dimensions here are going to be user type, if it's an existing user or a new user. And I give it 5 values for the region. So the region has 5 values. And we also have device, mobile or desktop. And I ask it for each segment, do these same tests, can you check for Simpson's paradox, can you do the guardrail checks, and for any degraded segment, look for our guardrail, which is the churn or not. Let's see what it comes up with. It probably might take a bunch of time because this, I would say, is like the more detailed. Oh, this is pretty fast. Nice. So look at what we have. So the lift is broad across most segments, but guess what? It found the guardrail to be degraded for new users. And the trade-off is that existing user churn dropped from them, but not as much. But for the regions, it's pretty fine. So the churn treatment users have essentially the same as churn control. So we are not losing like heavy or lightweight streamers, right? So, and the bottom line is that the regional playlist feature is a clear win for existing users, but is a retention risk for new users. The exact population Streamflow needs to grow. So if imagine we went to step 2 and we saw this win, and people didn't bother to look through segments of, like the critical user types, we wouldn't have understood that this is what was the issue, right? So for the new users, it was a retention risk. So now let's dive deep into now that we know this, what do we want to do? We basically, if you remember, going back to the theory that I talked to you about, it's not just statistical significance, but also practical significance. We need to understand the ROI. What is the impact of running this experiment and what is the, return that we're going to get with it? So let's do the step 4. How much time do we have? Okay. I know I'm running fast. Anything, Sean and Hi, you want to share based on what's happening in the chat while this runs?
I think you're good to go. There's a lot of questions. They're very disparate. We'll get to the things that we can't answer in chat in a bit in the Q&A.
Oh, makes sense. Awesome. Sorry, guys. I'm trying to run as fast as I can so that I could go through 2 demos with you, the Claude Web UI demo and also the Claude Code demo. I want to share all those details and also, if possible, have at least 15 minutes of Q&A at the end, which means we have 10, 11 minutes now. Cool. If this is going to take time, I actually have this run for us. How does this look like? Step 4, let's see if this is still running. Yeah, and another important thing that I wanted to share with you all is that if there are audience like who are listening to us today, if you do not understand the details of this, because I saw a bunch of non-tech folk, people who are in like, our stakeholders from design, for product also join. We have another course called AI Analytics for Builders. That's basically a course where we'll go through, it's not a weekend bootcamp. It's going to be a 6-week long course where we talk through every detail of how do we set up experiments, what are the metrics, and all of that with Claude Code. So almost like an enhanced version of the bootcamp, but that covers 6 weeks long. Yeah, you could look at all of that in AI Analyst Lab.ai as well. Okay, so it's actually creating the chart. So when I ran it to make sure that I have something for you guys, I didn't do the charts here. So for the demo, I was thinking it'll be cool to get a chart, and we did get a chart. That's pretty awesome. So this is something literally I'm doing right now with you guys, because I was like, let's have a thing with the chart. So I think this is something you can copy paste. Yeah, copy image. How cool is that? Okay. So what does this say? So it basically says that the churn feature reduced churn among existing users, saving and then 53,700 users worth 11.8 million in LTV. But if we shipped to new users, the churn spike would burn like so many. So yeah, this is what we would understand what happens when we look at things by segments, right? And also understand the lifetime value and ROI here. So the conservative scenario talks about deliberately zeroes out the churn benefit and still returns 21x the infrastructure cost. So even under the most cautious assumptions, this is a strong ship for existing users. Yep. Okay. So let's go to the step 5, which is the final prompt that we have. So I'm doing it step after step so that you go through this process with me for multiple questions, but we could have one single one-stop prompt as well that does this entire thing for you and gives you the docs and give you the deck and the doc as well. So when we share these results with you over an email, we will basically share with you every step-by-step prompt, and we'll also share with you the detailed one-stop shop prompt as well. Yeah, look at this. It basically talks about per segment ship decisions. What do we ship? What do we not ship? What do we iterate on? What do we ship? I'll be honest, generally, like in real time, it wouldn't be as feasible for you to ship like specific areas, for example, the Pacific region, right? So you want to do something at the cost of not maintaining it. So this is where I would say you would use this agentic system to get to you to a place where it does 80%, probably 85, 90% of your work. But there is definitely 10, 15, 20% of the work that you still need to do, because not unless and until you give it the entire context, which probably the more you work with it, the more context it gets and the better it gets at giving you these decisions. But there could be some reasons that, hey, shipping it to non-Pacific regions is something not possible for infrastructure. We possibly want to, do the entire ship and then iterate on it, right? Because we might not want like super custom product features as well. So that is something that you as a data person or a product person or stakeholder would make a call based on all the information that this provides. So yeah, look at the net annual impact, the retention LTV saved, and the net ROI. So this is the executive summary. Streamflow's regional playlist experiment is a clear win with one critical caveat, and it gives like all the details that I shared in the earlier prompts. So in this prompt, I actually did not share it to give me a Google Doc or like a doc, but I did in my previous prompt. So look at this. I actually asked it to give me a doc, and Claude Web generated a doc, guys. It's not a, I thought this was pretty cool. Look at this. It's actually and it's something that you could download. It's in a docs that you can edit and share. So I will share this other prompt as well. So I wanted to share more detailed prompt, and hence I did this for table structure. But it could also give you an actual doc that is, that looks actually pretty good, directly ship worthy. I'm sure you have to do a bunch of changes based on what you think is the right context, but it's in a pretty good place already. Okay, so let me stop sharing this and go for Claude Code prompt. Claude Code demo. Okay. Anything quickly, Hi or Sean, that you'd want to tell before I jump to the Claude Code?
I'm gonna paste in some upcoming lessons as well that might be interesting to this group as you're pulling up Claude Code, Sravya.
Yeah.
Would be all free and they happen over the next week or two. And it's also about Claude Code and just dropped it in there. Definitely register and you'll get the recording afterwards.
Awesome. I'm generally not seeing any messages, guys, so sorry if you have questions for me, but I quickly saw one message before I'm sharing my screen about, did Claude have context about LTV? Yes, it did. If I didn't give it the context about the RO, the ROI or average LTVs, it would, take a bunch of things itself and create scenarios. If your average LTV was so much, this is what you would get. If it was so much, this is what you would get. But for this demo, I gave it the context. Okay, now let's go to Claude Code. Cool. So for the people who were at the start of my of the lightning lesson today, you might have seen me given this context to this Claude Code. Sorry, give this prompt to the Claude Code, and we have a bunch of repos, like all our bootcamp repos here, all our AI analytics for builders, the course that we have all of this like in-depth knowledge that it could use to get this information. So let's say this is the analysis, this is the prompt. I'm running it again so that, oh, give me a minute. I actually want to run it and ask it to give me something. So it has the prompt to give me the entire, and I want to ask it, can you share with me a plan before you execute? Let's see what this is going to give me. So it's basically going to look through all of this. So I just gave it a permission. You could also give it, go to settings and permissions and change that, guys, to make sure it doesn't ask you for permission every time. But I try to do it for some things because I want to be a gatekeeper for some permissions. Look at the prompt, look at its plan that it's generating. So everything that I showed you in the Claude Web UI, it has all of this in its in its bank on how to generate this analysis. I'll go through this, but I want you to check out the prompt that I gave. So analyze experiment in Streamflow experiment.csv using the experiment analyzer agent. So this is the agent I created to showcase with you all how do we do experiment analysis in Claude Code and the inputs and all of this. And I also talked to it about using another agent at the end, then export the final readout as a Google Doc using Google Doc Creator agent. And also I talked to it about after the 8-question analysis it completes, pass the results to experiment readout agent. So I have a bunch of agents and skills that are inbuilt in my system that it uses to come up with an answer to this question I asked. And this is the business context that I gave, guys. Like someone asked this question, I briefly saw. Okay, so it actually goes through this entire prompt. This is the plan that it created. This is the data overview. This is the stage 1, like what it does, like all the steps, the questions it goes through. It actually creates an output for each of these in this. So if you're interested, you could go to this you could go to the directory. Like I have my lightning lesson 5 here. So it puts all of my stuff here. And stage 2, it does the experiment readout. It does this. Then it does the Google, in stage 3, it does the Google Doc export. Let's do something to make it easy for you guys to understand. I'll ask it, let me actually talk to it. Can you give me an ASCII diagram of your entire workflow? So this is what I do most of the times. I literally talk to it, not even type with WhisperFlow. So this is what it is doing. It takes all this knowledge that we built into the experiment analyzer agent and goes through all these questions that I put as part of the agent, when to do what for each combo, like what do you do, when do you pass, when do you block or halt, and like because you don't want it to run through all of this when you have issues at the SRM itself, right? So this is the stage 2. Once we have all of these, how do we do the readout? So ensure that you generate visualizations. If you see, we have a bunch of helper files that we have. A good chunk of this, I would say 60% of this or 50% of this is already part of our free repo, guys. So please check out the free repo. It's already in like something that Sean and I are sharing, and also it's an AI analyst lab.ai as well. But I did create a bunch of agents for this lesson. Specifically, I worked over the last weekend for this to basically understand how do you get these questions, but also do the readout in a way that you could literally share it with your stakeholder, right? So it reads and synthesizes, it designs the storyboard. How do you take the context? What is the tension and what's the resolution? This narrative is something that we built into our skills and agents, and we have different charts, and we write the narrative, we build the RAM plan, and the final one is the Google Doc. As simple as we think, Google Doc is not, I mean, once we have an agent and skill, it's probably easy, but it's not, it was not super easy the first time you did it because it does not have as easy access to where an image sits and where like the text starts. So you need to work with it to ensure the images and text have, a gap with each other and the formatting is right. So this is what it is. And let me share with you the final output once again. Yep. What am I sharing? Oh, wait, I'm sharing the wrong one. Let me share the right one. Yeah. Okay. Cool. So this was the doc that it shared. If you look at what we've done in the Claude Web UI, it's literally the same thing in a Google Doc format. I did Google Docs because most of the tech companies I know in Silicon Valley use Google, Google Workspace. So it basically did this. It did all the formatting, the colors, the original one was not that pretty. It made it pretty because we worked with it to make it pretty. The charts, like what exactly happened with new users and what's in Pacific region. And there's a Simpsons paradox. That's what it talks about. And these are the charts for the guardrail alert. And was the experiment run long enough? And what is the ROI impact? And it talks about the existing users shipping and the new users do not ship. And another cool thing is it actually created the deck too. I didn't get a good enough time to work on work. So we also have a Google slide deck export agent and also reviewer agent, but I don't have as much as many interesting things on top of it yet. That's something I'm going to work over this next week. But yeah, this is already what it generated. Not too bad. It basically talks about what like all validity checks being passed, what's the primary metric, and how does the segment reveal. So look at the segment reveal. So it just did it had some narrative built in. It talks about Simpsons paradox, what it gave, and lift by region, churn guardrail, like weekly lift trend, and finally the business impact. And it also gives recommendation. Again, all of this is nothing. I didn't do any code. I didn't do anything. In fact, I spoke to Claude Code because we have the system built in, the agents and skills. That's the reason why we got to this place. Okay. I think that's where my demo ends, guys. We have around 11 minutes. We have a hard stop at 1, unfortunately. So 11 minutes to take questions.
Hey, Matt. Well, good to see you, Matt.
Hello. Um, Quick question about like accuracy. You seem to be, iterating through this very quickly and just trusting it. Like if let's say you were responsible to give a report to the CEO and your job was on the line, how would you change the workflow
I can, I can,
if you weren't giving a demo?
I can
Just
take
give,
it. I can take it, Sravya.
Yeah.
So here's my philosophy around anyone using Claude Code for analysis. You're accountable. The human is accountable for the results of AI. No one gets to go to the CEO and say, "Oh, the AI screwed it up." Just like any analyst, like if I gave my results to my manager and he reported that out without taking a look at it, like that's on him too. So there's many ways to validate this. One thing I like to do is go through and run it on a bunch of back tests of analyses I've already ran in the past. See, you can just even like one-off do this yourself. I have it basically also take any of the Python and SQL and I have it put it into a Notion document with the results so I can validate that there too. You can also build like extensive AI evaluation kind of metrics around the validity of this too. So if you have like 300 ground truth experiments you've ran in the past, whatever year or so, or 2 years, you can run this on there and do some sort of like auto research thing to optimize the like performance of that in terms of like how accurate the results of this were versus like the human ones back there. So definitely like there's ways to have structured validation like any AI product. But at the end of the day, I think like you have a very good point. Like, don't just trust it and give it to the CEO, like, because it is your job and you gotta like be accountable for that at that point. Does that
Yeah.
make sense?
One thing I'd like to add to what Sean said, Matt, is that what's the intent? Like, what's the goal of this lightning lesson, right? The lightning lesson goal is not that, hey, take this AI agentic system and you don't have to work anymore, or or just you let it work and you give it directly the output. Not at all. What the goal is, it is pretty smart and intelligent, and we could make it do half or way more than half of the work, that you basically let it do the work and you decide on what you like or what you have problems with it, and work with it, give it the feedback and let it run. I agree, Matt. This was a demo. I know it. I probably did give it like something that I could share with you all, but that does not mean that this is always going to do some great things, right? There are a bunch of things. I'm running it in my company right now, and there are so many things that it also gets wrong. But guess what? The more I work with it, the more I get the skills and agents to a good place, the better it gets in the next iteration. And I'll be honest, I'm banking on the newer model that's going to come out in like maybe 2, 3 months. And I don't probably need to work with it as much as I worked with it now to get to a good place that I could present my findings to CEO directly, right? Yeah. So Joy,
Uh,
sorry, one thing, Matt. Anything else you'd like to ask, or are we good? We could
No,
move to.
that's
Yeah.
good for now. Thank you.
Okay. Awesome. Yeah.
yeah, Shavya, I had a quick question. So, could you maybe share which agent is doing what work in the different steps of the experimentation? Because I saw you had like multiple agents, right? So, if we could get a quick walkthrough of which is tasked with doing what in the entire Cloud Code process.
Yeah, we only have 6 minutes, Joy. So I'm wondering if I start doing that, it'll probably take the entire time. What I can do is probably in a follow-up after this lesson, I can try to give some, summary so that you could learn from it. And I'll also be honest, I'm not sure if we could cover all of that in a summary in like even if I take 6 minutes. So that's the reason we plan to do all of that in a lot of detail in the bootcamp, and also the 6 week long course where we get into a lot of depth. So if you're interested, please check them out. But we'll also try to give you stuff for free or in links as much as possible. Okay? Awesome.
Sravya, there's a really good question from Maxine on what's your perspective on someone junior who hasn't yet built the knowledge or skills to fully validate outputs themselves? Do you think the level of reliance on Claude should be limited, or more emphasis be placed on learning through feedback from others?
Oh, I love it. I think this is all the problems that we are dealing with as data leaders in this space. Like, this is something that I'm thinking through literally myself. I have a team of 12 to 15 people, and it's the problem of the hour that we are trying to solve um, with evolving AI. To me, I think you had it in your question itself. I would have accountability on area owners or metric owners or like the tech leads of the space to ensure that the skills and agents and the context that's built into it is reliable, is up to date, and is something that people could, check and review with the lead before they output something, especially the newer ones. Until we get it to a place where, let's say we get it to a place where 95, 99% of the reviews always are passing with the tech leads or with the area leads of that area of that metric, then yes, maybe we are getting into the newer system or a new model where it's almost getting it right most of the time with the context we provide. But that said, it is also very interesting that the the newer grads or the recent engineers have way more flexibility and adaptability to work with AI. So that's, I think, a great thing for students and people who are passing out or who are like newly in this field, that they could leverage all these systems to understand and work with how to work with it to give feedback while relying on the subject matter experts and the area tech leads of data or engineers or whatever to ensure that whatever they produce goes through their review. Greg?
Hey guys, could you touch again on how you have Claude learn from any mistakes you find when you're double checking its work?
Yeah, you talk to it is, I would say, the most simplest thing. But I mean, the multiple things that you understand when you ask the same question, Greg, to it. You basically tell it, this is a clear discrepancy. I would not expect you to make this mistake. What do you need to be corrected in your system to make this happen, right? So there is a Claude itself tells you, oh, I basically don't know this gap, and this is why I made this mistake. It actually tells us where it goes wrong as well, along with you yourself identify, right? Because we are the area experts of whenever we ask the question. So I would thoroughly encourage people when you work with these systems to work on the areas that you entirely know the nitty gritty details about, because only when you know all the nitty gritty details you could find these flaws that Claude itself probably can't find or ignores or jumps between loops and tries to assume things, right? So I would say half of it, that Claude itself, once you point out that, hey, this is wrong. Why did you get this wrong? It gives like a reasoning for why it made that decision, and you understand why it made in that reasoning. And a part of it is what you would identify as part of when you look through what did you do to get here. And when you look through that workflow, you can understand that, oh, this is probably the reason why it got wrong. And you talk to it and ask it as well. Yeah.
There's also I'll send you this article, Greg. There's this
Yeah.
thing that people are doing from Carpathy called auto research, which is really cool to like automate some of this, where it'll basically it only works if you have a bunch of ground truth to test on. But like I was saying, if you have like a bunch of historic experiments, basically like it'll train on the experiments and then it'll try its an attempt at the experiment and then it'll look at like the historic thing of like, oh, what's all the stuff I did wrong, and actually do its own error analysis that's like by different dimensions of what it got wrong, and then it'll feed that back into the agent and say like rebuild your system, like whether it's your knowledge base, skills, or agents, and then now try it again on another test experiment. And you have to create some metric, like you could have some like similarity metric or some sort of metric of accuracy. And it just like loops like that in a like forever process until it optimizes that metric. I've been doing that for a few different systems I've been building out, and that's like a really cool way to get it to bake in all of its learning back into the system. But I'll send that to you. It's like a pretty new thing.
Awesome. Yeah, I think I was even thinking about just maybe simpler tactical technique, like how to have it correct its own mistakes. So it's equivalent of like taking your dog, your puppy, and rubbing its nose and something, correct it to reward it and or punish it when it to so it doesn't do the same
Yeah.
mistake twice.
Yeah, a quick answer to that is you ask it to think about why it made the mistake and don't do
Yes.
it again, and then it's generally pretty good, and then you do it incrementally.
Yeah.
Cool.
Okay, we are almost at time, guys.
Yeah.
Unfortunately, we have a
We
hard,
are.
but
Yeah, I think we're out of time. So for people who are looking to ask more follow-up questions, I think there's a bunch of engagement here. Thank you all so much. Definitely hop into our Slack channel. We'll have, if you post those questions, we'll be able to answer them over there. Otherwise, we'll send out all the links and stuff.
awesome. It was amazing, guys. Thank you so much for joining our lightning lesson. Any questions? We are all three active on LinkedIn. So, message us, comment on our posts, what else you need, and check out more on AIAnalystlab.ai. Okay?
Very good.
Cool. Bye.
Thank you.